Hello friends, in this video today our topic of discussion is equation reducible to exact differential equation, and here I'm going to explain how to solve I'm going to explain 5 different rules to solve 5 different forms of equations which are not exact differential but they are reducible to exact differential equation. So link of the previous lecture is given in the description box. Please go through it. So now let us start. Suppose we have equation of this form m dx plus n dy is equal to 0. So we know that we have already discussed in the previous video del m by del y is equal to del n by del x. If these two are equal, then it is said to be exact differential. But if not equal, then how to solve? If suppose del m by del y is not equal to del n by del x, then the first rule, what we're going to do, first we are going to find del m by del y minus del n by del x. Then we're going to divide this one by n. Then if it is if it can be expressed in this form f of x, then what we are going to do, then our integrating factor will be e to the power integration f of x dx. Okay, then we will multiply this equation, given equation, suppose it is equation number 1, by this integrating factor e to the power integration f of x dx. Then we will integrate to get the solution, as we did in case of exact differential equation. That first what we do, we will after multiplying this, again we will get an equation of this form m dx. Let us take m dash here, then n dash dy suppose is equal to 0. We will get this form after multiplication of this integrating factor with 1. We will get this one. Then again what we will do, again we will integrate m dash dx with respect to x. We will integrate this. Then next we will integrate the terms which are not containing x, terms in n dash not containing x dy is equal to c. So we will integrate this way, then we will get the solution. So this is first rule. Now you see this expression, in all cases you cannot express in this form f of x as a function of x. So in that case, suppose rule number 2, then what we are going to do, then we will find del n by del x minus del m by del y. Then we're going to divide this one by m. Then we will get it is a function of y. Then our integrating factor will be e to the power integration f of y dy. Then we will proceed in the same manner that we have done in the rule number 1. Okay, we will multiply the equation with the by the integrating factor, then we will integrate in the same manner. So hope you have understood this. Now let me give you 2 examples for these 2 rules. Okay, suppose we need to solve this equation. Here you see, so our m will be, in this case, if you compare with this form, m dx plus n dy is equal to 0, then m will be here y minus twice x cubed. This is our m, and n is minus x into 1 minus xy, and if you multiply it, then minus x plus x square y. That's what you will get. So now let us find del m by del y. So if you differentiate m with respect to y partially, then you will get 1 here only, and our del n by del x will be equal to minus 1 plus twice xy. That's what we will get. So here it is clear that del m by del y is not equal to del n by del x. That means it is not exact differential. So what we're going to do, so we have to find del m by del y minus del n by del x and if we divide this one by n, and if it can be expressed as a function of f of x, then we are going to find the integrating factor as integration f of x dx, isn't it? And this is rule 1. So if it is not possible to express in this form, you cannot express this one as a function of f of x, as a function of x, then what we can do, then del n by del x should be del n by del x minus del m by del y should be divided by m, and then we will try to express in this expression as function of y. Okay, then our integrating factor will be e to the power f of y dy. So first let us check this. Okay, first let us apply the rule 1. So is that possible or not? So now here you see, so this term will be 1 minus 1 plus twice xy, and divided by n. Our n is this minus x 1 minus xy, isn't it? So then it will be 1 plus twice xy minus x 1 minus xy. Then sorry, what I have done here, this should be negative, isn't it? So that's going to be equal to 2 minus twice xy by minus x into 1 minus xy, and after simplification, taking 2 common, 1 minus xy by minus x into 1 minus xy. If you cancel these two, then you will get minus 2 by x. So here it is a function of f of x. So let's find the integrating factor. So let it be equation number 1. Let us give this given equation as equation number 1. So our integrating factor will be e to the power integration f of x dx. That's going to be equal to e to the power integration minus twice 2 by x dx, and that's going to be equal to e to the power minus 2 log x, and it can be written as e to the power log of x to the power minus 2, and here we have used the property of log, that m into log of n, that's going to be log n to the power m. So we know that property that is used here. So now here you see, remember this, e to the power log x is nothing but x. So here it will be e to the power, we have log x to the power minus 2, so that's why it's going to be x to the power minus 2 only, and which is equal to 1 by x square. So this is our integrating factor. So equation number 1, this equation number 1 will be multiplied by this integrating factor 1 by x square, and if you multiply this equation number 1 by this integrating factor, then what you will get? So equation number 1 is multiplied by 1 by x square, and doing so, what we have got, y by x square minus twice x dx. Then if you multiply this 1 by x square with this term of equation number 1, then what you will get? So let me minimize this so that you can see both the equation and what am I doing here. Now 1 by x 1 minus xy dy is equal to 0. 0 into anything is 0. So that's what we have got. Now, so what is our next step? Our next step is to integrate. So how to integrate? So this sign should be implies. So this is implies here. So what we're going to do? So the term which consists dx. So we're going to integrate this term with respect to x minus twice x dx. Then so we are going to integrate those terms only from this part which consist only y, which do not contain x. So if you multiply this, then you will get that minus 1 by x plus y, isn't it? If you multiply this one and this one, then you will get this. So this is term containing x, so we are not going to integrate this, we are going to integrate only this term. So integration y dy is equal to 0. So hope you have understood till now. Sorry, here it should not be 0, it is constant, suppose c. Okay, so now let us integrate this. So as we are integrating this one with respect to x only, so y should be taken as constant in this case. So then if you integrate x to the power minus 2, then what you will get? Then you will get, so let me write directly here, x to the power minus 1 by minus 1, and that is nothing but, we can write this one as this minus y by x. That's what we get after integration. So if you integrate this minus twice x term, then you will get minus twice 2 x square by 2, so 2 to cancel, so we have got only in this case x. Okay, so we have got minus x only, sorry, not only x, minus x square. And if you integrate this one, then what you will get, y square by 2 equal to c. So that is our solution. That's how we can solve. So now let me show you. Now here you can see, let us solve this equation. This is suppose equation number 1. So here our m will be, this part will be m, which is with dx. Okay, so y log y, and our n will be here x minus log of y. So del m by del y will be, so in this case what will be del m by del y. So use the product rule here. So using that, y into 1 by y plus log of y into 1, that means log y you can say. So here it is cancel, so we have got 1 plus log y, and del n by del x, so here it will be 1 and this is gonna be 0, as partial differentiation of log y with respect to x will be 0, isn't it? So here you can see these two are clearly not equal. So now you see, in this case, if you find del m by del y minus del n by del x divided by n, and then you will get this. Let me show you directly. If you divide, if you subtract this one from this, then you will get log y only, log y, then divided by n. Sorry, here divided by n is this x minus log of y. So here you see, so we have log y here and we have x here, so you cannot express this right hand side as a function of x. So that's why what we're going to do, we are going to find del n by del x minus del m by del y divided by m. So if you find that, so let me clean this part, sorry. Now you see, if you subtract del m by del y from del n by del x, then what you will get? If you subtract this term from 1, then you will get minus log y, and divided by m is y log y, so here you will get y log y. So here log y gone, so we get minus 1 by y only. So here it is a function of y, so it is a function of y. So now what will be our integrating factor then? So our integrating factor will be equal to e to the power integration of f of y with respect to y. So that's going to be equal to e to the power minus integration 1 by y dy, and that is nothing but e to the power minus log x, sorry, not x, y, log y, and it can be expressed as e to the power log of y to the power minus 1, and which is nothing but 1 by y. That's what we will get. Our integrating factor is 1 by y. So hope you have understood this. Now this is equation number 1. So we are going to multiply this 1 by y with equation number 1. So then what will happen? If you multiply 1 by y with this term, then this y will be cancelled, and here if you multiply 1 by y, then it will be x by y, and here it will be log y by y. So hope you have understood this. Now let's multiply. So multiplying 1 by y with equation number 1, so we get log y dy, sorry, not dy, dx plus x by y minus log y by y dy is equal to 0. That's what we have got. So now what to do? We're gonna integrate this part, log y dx. So here you see this part consists y only. That's why we can write this one in this way, log y integration dx. We can write this way. And from this part, what we're going to take, we are going to take those terms only which are not containing x. That means this term x by y should not be taken. Okay, from this part, which part consists del y, from that we are going to take those terms only which are not containing x. Okay, so remember that point. So integration, here we will take minus log y by y, so that means you can write this way. So minus integration log y by y dy is equal to c. Here we need a constant here, so you can integrate this log y by y dy using substitution method. Log y is suppose t, then what we will get, if you differentiate with respect to y both sides, then you will get 1 by y is equal to dt by dy. So that means then this part will be 1 by t dt, and that is t square by 2, and t square is nothing but log y square. That's going to be log y square by 2. That's what we will get. So hope you have understood this. So log y integration of dx is nothing but x, so we can write x into log y minus, and integration of this we will get log y whole square by 2. So let me write properly, log y whole square by 2 is equal to c. That's what we will get. So hope you have understood. So let me take this one as c dash, suppose c dash. So now multiply both sides by 2, then you will get twice x log y is equal to log y, sorry, minus log y whole square twice c dash, and takes twice c dash as capital C. Suppose then this is your solution, log y minus log y whole square as capital is equal to capital C. So here you see the c dash is constant, 2 into c dash is also constant, so let us take this whole constant as capital C. So this is our solution. That's how we can solve such kind of equation. Now let me show you another example. Now here you see, suppose we have equation of this form, suppose, and this is m and this part is suppose n. So our m is suppose y into function of f of function of xy, then x into function of xy again. So then this is suppose n. Then our integrating factor will be 1 by mx minus ny. Then we're gonna multiply this integrating factor with this equation. With equation number 1, we're gonna multiply this integrating factor. Then again we gonna integrate this whole part after multiplication of integration factor. And then we're gonna take the so suppose this part is m dash. After multiplication of integrating factor with this part m, we get suppose m dash dx, and next term suppose after multiplication of integrating factor, this term becomes suppose n dash, and we are going to integrate this n dash with respect to y, and here we are going to take only those terms not containing x. We are going to take only those terms which are not containing x, and here we will get a constant. So let me give you an example. Now suppose we need to solve this equation. Now here you can see this is in this form, y into f of, suppose f1 xy, f of xy. So it is a function of x and xy. So here also it is in this form, x into f2 of xy. So in this case what we're going to do, so our m will be y into 1 plus xy, and n is x into 1 minus xy. So that's why mx, what will be mx here, m into x will be xy 1 plus xy, and ny will be xy into 1 minus xy. So if you multiply these two, then here xy plus x is xy whole square, and here you will get xy minus xy whole square. That's what you will get. So our integrating factor in this case, it will be 1 by mx minus ny, isn't it? We will this will be our integrating factor. So if you do so, then what you will get, 1 by, if you multiply this mx, subtract ny from mx, this is mx, and if you subtract this one ny from this mx, then what you will get, so these two terms will be cancelled on subtracting, then xy whole square plus xy whole square, that's what you will get, and that is nothing but 2x square y square. Okay, so this is our integrating factor. So this is equation number 1. Now let us multiply this integrating factor with this equation, 1 by twice x square y square. Then if you multiply this integrating factor with this one and this one, and if you simplify, then what you're gonna have, then this equation number 1 is going to reduce to this form, equation number 1 into 1 by twice x square y square, and that's gonna give you 1 by twice x square y into 1 plus xy dx plus 1 by twice xy square into 1 minus xy dy is equal to 0. That's what you will get. If you multiply this one with here with this term, so x square y square, so 1 y will be cancelled with this y, so that's why we have got this here you see 1 by twice x square y, isn't it? So similarly here you see, if you multiply this term integrating factor here with this x, so then 1x will be cancelled, then here we will get this. So hope you have understood this part. So very simple simplification, nothing to explain in this case. So now, so from here if you simplify this equation, then what you will get, so let's simplify, then 1 by twice x square y, and then you will get 1 by twice x dx, then here you will get 1 by twice x y square minus 1 by twice y into dy is equal to 0. Now what you will get, here you see we have to integrate this complete term, and we will integrate the terms not containing x from here. Okay, we are going to integrate only those terms in this expression which are not containing x. So first integrate this first part with respect to x dx plus integration 1 by twice x dx, then here we will take only the term which is not contain which are not containing x, that means 1 by 2 1 by y, that's what we will get. We are going to take this part only, dy is equal to 0. Now let us integrate this. So here y to be considered as a constant in this case, as we are going to integrate with respect to x only. So then what you will get, so 1 by 2 y will be considered as constant, and integration of x to the power minus 2, that's going to be equal to what, that's going to be equal to x to the power minus 1 by minus 1. So that's why what you will get, in this case. So you can write this term as this way, 1 by you can write minus 1 by twice xy only, integrating this first part, and here you will get 1 by 2, and integration of 1 by x is log x, and here 1 by 2 log y is equal to constant. That's what you will get. This 0 should not be 0, that should be constant, actually constant of integration. So here you can see what we're going to do. We're going to multiply each term by minus twice xy. So if you multiply all the terms by minus twice xy, so let it be suppose c dash. Okay, so then we will get here plus 1, and here it will be minus xy log x, and it's going to be plus xy log y, and here right hand side will be minus twice xy c dash. That's what you will get. Okay, so hope you have understood this. So now here, and this one on the other side, here we will get xy log of y, taking xy common, what you will get, log y minus log x. So on the other side, minus xy, you can consider this one as you can consider xy into minus 2c dash. This part is constant, and 1 is on the other side, it's going to be minus 1. So xy, and here use the property of log, then what you will get, log y by x. That's what you will get, and xy, and consider this minus 2c dash as c, capital C only, then minus 1, where c is equal to minus 2c dash. That is nothing but constant. So this is our answer. That's how we can solve. This is rule 3. So here you see, if you have a differential equation of this form, then how to solve it? First, again, we are going to find the integrating factor, and here integrating factor will be such that x to the power h into y to the power k, and h and k are such values that following here you see this equations will be satisfied. M plus h plus 1 by a is equal to n plus k plus 1 by b, and one more condition, m dash plus h plus 1 by a dash plus equal n dash plus k plus 1 by b dash. So these two conditions must be satisfied. So we have to choose such values of h and k. Then again we will multiply the integrating factor with this original equation, then we will integrate, and that's how we can find a solution. So let me give you an example, then you will better understand. So let us take a question here. We need to suppose solve this equation. So equation is suppose twice y dx plus thrice x dy plus twice xy thrice y dx plus 4x dy is equal to 0. We need to solve this equation. Now here you see, in order to compare this equation with this above equation, above form, what we can do, here we can consider we have x to the power 0, y to the power 0, then value of m and n will be 0, and here you see we have x to the power m dash and y to the power n dash. So that's why and here you see there is only 1. So we can what we can do, we can multiply these two with this expression inside the bracket. So we will get x and y only as we have here. So and here we can consider m dash as 1, y dash as n dash as 1. So x to the power 1, y to the power 1 we can consider. So let me simplify this equation. So this equation will be twice y dx plus thrice x dy plus xy 6y dx plus 8x dy, you can consider that way, equal to 0. Now if you compare this equation with this form, then you will get the value of m and n both equal to 0 here, and m dash and n dash both equal to 1 in this case, and a is the coefficient of this y and coefficient of this x. Sorry, here this one written mistake, sorry, I have made a mistake here, so this one should be dy. Okay, so now this is a, this is b, this is a dash, this is b dash here. Okay, so our a is 2, b is 3, and a dash is 6, and b dash is 8. Okay, so we have got the values of a, b, and m, n, and m dash, n dash, and a dash, b dash. Okay, so we have got those values. Now what are the conditions to be satisfied by h, k? So these two conditions to be satisfied, so let me show you now. So what were the conditions? M plus h plus 1 by a is equal to n plus k plus 1 by b. Now let's put value of m and n. So here you will get h plus 1, value of a is 2, and value of b is 3 here. So here k plus 1. Then if you simplify this, after cross multiplication and simplification, you will get k is equal to 3h plus 1 by 2. So this is suppose equation number 2. So let us consider this given equation as equation number 1, and this is 2, and our next condition was m dash plus h plus 1 by a dash, that's it, should be equal to n dash plus k plus 1 by b dash. Now let's put the values of m dash and n dash, then put the value of a dash, b dash. So here m dash is 1, n dash is 1, so if you add 1 with 1, 1 with 1, then you will get h plus 2, and on the other side you will get k plus 2, and a dash is here 6, and b dash is 8. So we have got this, and if you simplify this equation, then you will get something like this, 8h minus 6k 12 minus 16, that's going to be equal to minus 4. Now let us replace this k by this value. Okay, so if you put that value here, then what you will get, 8h minus 6 into you will get 3h plus 1 by 2, and here we have got minus 4. So this is using equation number 2. Now cancel it by 2, then you will get 3 here. So after simplification, what you will get, let me scroll down, 8h minus 9h minus 3 minus 4, then if you simplify this, minus h will be equal to minus 4 plus 3, then that's going to be minus h equal to minus 1, that means h is equal to 1. So let us put this value of h here. Okay, putting h is equal to 1 into, if you put the into this value of value of h, if you put the value of h into, so then what you will get, k is equal to 3 into 1 plus 1 by 2, that's going to be equal to 4 by 2, which is equal to 2. So value of k is 2. So we have got value of h and k. So that's why we can find integrating factor. So our integrating factor is given by, in this case, x to the power h and y to the power k, and putting the values of h and k, we have got x to the power 1, that is x only, y to the power k is nothing but 2. Okay, so this is the integrating factor. So now what is our next step? Next step to multiply this integrating factor with the given equation. So this was the equation obtained from the given equation after simplification. Let us multiply the integrating factor with this equation number 1. Okay, let me minimize this space. Okay, so if you multiply this equation with equation number 1, so equation number 1 into integrating factor, then what you will get? So if you multiply xy square with each and every term of this equation, of this equation number 1, then what you will get. So let's multiply that and simplify. So if you multiply here, here and here, then what you will get, so you're gonna have twice x y cube dx plus thrice x square y dy, then you get 6x square, not yes, x square y to the power 4 dx, then 8 x to the power 3 y cube, 8 x cube y cube dy. That's what you will get, equal to 0. So what we have done, we have just multiplied x y square with this equation. We have multiplied x y square here, and here also we have multiplied x y square. Okay, then on the other side also x y square. So x y square, 0 into anything is 0, and if you multiply this and if you open the brackets, then you will get this equation that we have got now, this one. Okay, now if you simplify this, here you can take from this to you can take dx common, and from this to you will take we will take dy common. Okay, so then after simplification you will get twice x y cube plus 6 x square y to the power 4 into dx, and plus thrice x square y square plus 8x cube y cube into dy. That's what you will get, equal to 0. So now again what we're going to do, the term which consists dx from here, that's we're going to multiply, sorry, not multiply, we're going to integrate each term of this expression. So 2 integration x y cube dx, we're going to integrate with respect to x, and then 6 x square y to the power 4 dx, and from here you see we are going to integrate only those terms which are not containing x. But here you see there is no such term which doesn't contain x, so that's why we have to ignore this part completely, because there is no term not containing x. So that's why we have got what we have got, that is equal to constant c. Okay, so that's what we have done. Now let us integrate. So 2 into, if you integrate x, then you will get x square by 2, then y cube should be treated as constant here, and 6 into x square will be x cube on integration by 3, then y to the power 4 should be treated as constant, is equal to c. So let's cancel, then our final result gonna be equal to x square y cube plus twice x cube y to the power 4 is equal to c. So this is our result. Or you may take common, what you can take common, x square y square, you can take this common, sorry, y cube. So then here you will get 1 on taking this term common, and here you will get 2, x square is taken common, so here x, and here you will get y only, is equal to c. So this is our solution. That's how we can solve such kind of equations. So now let's move on to next rule, rule number 5. Now suppose we have equation of this form, suppose m dx plus n dy is equal to 0. It is suppose homogeneous. But mx plus ny is not equal to suppose 0. In that case our integrating factor will be 1 by mx plus ny. Okay, then we are going to multiply the integrating factor here, then we are going to integrate. So let me show you one question. Let me take a question. X square y dx minus x cube plus y square, sorry, y cube, not y square, dy is equal to 0. So here our m is, this one is m, x square y, n is equal to x cube plus y cube, and so mx will be x cube y, and ny is gonna be equal to minus x cube y minus y to the power 4. So here you can see mx plus ny. So if you add these two, then what you will get? You will get here you say these two terms will be cancelled on adding. So you will get minus y to the power 4, and which is not equal to 0. So therefore our integrating factor if, that's going to be equal to 1 by mx plus ny, which is equal to 1 by minus y to the power 4. That's going to be the integrating factor. So this is our integrating factor. Now we are going to multiply this with this given equation. Suppose this given equation is 1. So let's multiply this integrating factor with equation number 1. So equation number 1 into minus 1 by y to the power 4, and if you multiply that here, then you will get our equation on simplification will be x minus x square by y cube dx plus x to the power 3 by y to the power 4 plus 1 by y dy is equal to 0. Then what we are going to do? Then we are going to integrate this part minus x square y cube. Y should be considered as constant in this case. Then we are going to integrate only those terms in this expression which are not containing x. So there is only one term, that is 1 by y, which doesn't contain x. So integration 1 by y dy is equal to c. That is the constant of integration. Then so we know that integration of x square will be x cube by 3, and y cube is taken as constant in this case, then plus an integration of 1 by y will be log y is equal to c. So this is our result. That's how we can solve. So hope you have understood this, how to solve such kind of equations. So if you have understood, please share with your friends, and if you are new to my channel, please subscribe the channel and inspire me to create new contents for you. Thank you for watching. See you.